Hello everyone. So we are back again. In the morning, we discussed some more things about pointers and memory. So this is the code that you can see on the right hand side of my web. You can see this was the thing which we discussed in the morning, and on the left hand side, this was the thing we discussed last time, couple of days back. So in the morning, what we discussed, what we tried to understand about the array of characters. So array of characters is something like a pointer. So for example, we defined a character array of message and keep it like a and the value it has was hello, and when we try to pass that specific variable, it does not get passed as an array of characters, rather than it gets passed as a pointer to to the first element in that specific array. So if you try to print the value of the first element, you can directly use this variable msg, which points to the memory location of the first element. And if you want to go to the second element, you can use pointer arithmetic and increment the address by one, and you will go to the second element. And if you want to go to the you can go to the second element. Yes, exactly. If you want to go to the third element, you will increment the address, the first address, which is also the message, by two. And if you want to go, you can also use this sort of arithmetic. So all these things, if you try to understand all these things, uh, pointer to MSG plus one, sorry, pointer to MSG plus one, or pointer, or what we can say, yes, MSG, MSG2, MSG1. So both these things are similar. Whatever you are trying to print, it will print the same value. Because what it does is it first takes the pointer at MSG and increments by one, and then print its value. This also does the same thing. Okay. And there was some more notation, but we don't focus on those notation. Yeah, there was one more notation. They were saying, yeah, I like this. It is also the same thing, but we will keep focus only on these two notation. We don't need to remember each and every notation. Also, if you want to understand the size of some specific array, we can use this sort of arithmetic operation to get the size. For example, size of list. This will give us the size of the whole list. For example, a single integer takes 4 bytes of memory. So there are 5 integers, it will take 20 bytes of memory, and one specific integer takes 4 bytes of memory. So 20 divided by 4, size will be 5. And here we can see we have used some sort of offset to print. We are passing the pointer to a character. So it will store the memory of the first character, which we are passing from here list. It will pass the address of the first character. So here we pass it, and then we pass the offset size. For example, which element you want to print. Print content, sorry, here print content 11. So what it will do is it will skip first 1 2 3 4 5 6 7 8 9 10, and it will print all the elements after that specific memory, so which was captured. So that is why puts. If you want to print a single specific character, you can use %c operator. If you want to print the whole screen, you can use puts, or you can use %s, because what %s does is it will keep on continuing. It will keep on picking the characters until it finds a sentinel character that will go back. So this is the basic explanation which we discussed in the model. Now we have to move out forward. And also we discuss something about scanf. So because scanf, we have to mention how many number of characters or how many string we can want to, but we didn't code for scanf. So let's right now what we will do is we will open a new tab new, and let's create a scan.c. Okay, scan.c. First code has include the then in name, and inside this integer function, what we are going to do is we will print something simple. What is your name? Then we will create an array of characters. So name, which is a, for example, the max value you have given is 20. Only 20 characters are allowed. So if we are going to scan. Uh, then we will ask it how many number of characters you want to take input from the user. So for example, 19 is only. So it will start from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have already seen this, and we will take this. And here, the point here is scanf takes the second argument, second argument in scanf. Scanf is the address. It is basically an address. So we have to remember this. This is an address, this is a pointer which will point to the name variable, first element in the name variable. So it will store it. Then we can print up my name in person, the person first level. Okay, now we can execute it. This is it. So scan proxy and we can execute it. It will ask what is the name. Can type anything. Okay, it prints out. And one thing which we observe here is we don't need this for this. Okay. Now the big challenge which we try to understand is how many number of characters will be played. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 19, and it will only be 20. More than 20, it will not play. It only be 1, 2, not only 19 because we mentioned 19, so it only be 20. But it has the capacity to, I think, read 20. Okay. It can read to 20. But what if the code was trying to tell us, for example, we have only mentioned 4 here and we are passing percent as classes and giving any specified address. This code is very dangerous because what it will do is, for example, I am traveling only 4, then it is fine. But what if I am giving more than 4? Then what will happen? It has the capacity to override the memory and also buffer overload. So that is the problem. Till 6 it detected, but then it tried to write some extra memory which was not allowed. That's why the code breakdown. So it is not the right way. Then now we are going to discuss the correct way, and that was fgates. Okay. Let's try to correct. We can also rewrite system. And I think 4 was allowed because 3 because the last character must be Sentinel. So that's why this one can be considered. That's why they have only kept 19, not 20, because the last address will be reserved for the Sentinel character. fkits. Fkits is an alternative to scan. There is another function you can use to enter text data fkits. Just like scanf function, it takes character pointer, but unlike the scanf function, the fkits function must be given a maximum length. Okay, so let's try to understand. So we have char put 5. We create an array of character which has the maximum length of 5. Enter your favorite put. fkits put. Then we can give the first it takes the pointer to a buffer. Okay. Next it takes the maximum size of the string \0 included, and stdin is basically the reader, basically the stream. Just means the data will be coming from the keyboard. Basically it is the stream where it will feed the data from. So standard input is the default. So we can also what we can try to understand fkits. So first is the name of the variable. Second is the size of, so how many length of the buffer we want to read, and the third one is where do we want to reach at. Okay. Data will be coming from the keyboard. It is basically a reader where we want to read the data from. That means that you can accidentally forget to set a length when you call fgets. It is right, there is a function signature as a mandatory or. Also notice that the fgets buffer size include the final character backslash 0. So it is very important to remember this size of also includes the backslash 0 pointer. You don't need to subtract 1 from the length as you do with scanf, as you do here earlier. Version 3s for character array of characters of whole. Okay, let's try it. Let's try it. So it is asking, okay, what is your name? So we will call fgets, and we will pass the pointer. What it is called? Remember, the pointer to a buffer. It is a buffer, correct? Array of characters. So our buffer is name. Name. Then we will try to print size of name, and then we will print this factor. Let's try to compile this code. Correct? Then, oh my god, what happened? I didn't even type anything. My name is XP. Where does it come from? Okay, so size of is not the correct way as per their explanation. Let's assume the size is 4 till now. Okay. Now let's compile again because we understand the problem with size of what is the name. So let's assume only 4 characters is allowed. HVL. My name is HVL. Because the 4 involves 4 including the sentinel character. You have to understand 4 including the sentinel character. Okay, so we have to keep this in mind. The string also has sentinel character. We have to keep that in mind. That the sentinel character is very, very, very important. Okay. 4 including the sentinel character. Very important. We can't do something like more than 2. These or that interesting. So using size of an fgets, the above code above sets the, so we try to understand what are the size of grids. Size of grids, the if we try to understand size of the total, I'm unable to understand, to be honest with you, properly what is the size of it. Let's try to read it again. Read it from the internet. The size of operator is used to find out the size of the variable pointer array or expression passed to it. It is generally useful in finding out the amount of memory space and bytes needed to store a variable, a pointer array, or the result of an expression. Ever wondered how much memory a data type occupies? We know that if we are going to mention it size of int, it will give the 4 bytes or it will give the 8 bytes. That is totally dependent on it. But size of operator is seen differently depending on operand data type, variable, array pointer. So it is based on that. So data type variable. In the parameters of data type, it will give. When the parameter is a variable name, is the name of the variable provided by function number of bytes to determine number of bytes. But expression pointer, when the parameter is a pointer, we are passing it to a pointer. Pointer is a pointer provided to the function to determine the number of bytes. The pointer would explain the number. So that is our problem. We are passing it a pointer. See, that is our problem. What we are trying to do is we are passing here a pointer. If we are using size of code, we are passing here a pointer. That is not the correct way. So we have to pass it here the actual length. Now let's see what it does. Be careful with this. Remember, size of returns the amount of space occupied by a variable. In the code above, food is an array variable. So size of returns the size of the array. If food was just a simple pointer variable, the size of operator would have just returned the size of a pointer. which is what happening in our case. So he has created an array variable. Array variable. So we have also defined it as array variable. If you get that you are passing the size of an array variable to fgets function, then use of size of is fine. If you are passing a simple pointer, you will enter the size you want. So seriously. Fgets function actually comes from an older function called gets. Even though fgets is seen as a safer to use function as scanner, the truth is that older gets function is far more dangerous than either of them. The reason the gets function has no limits at all. Gets is a function that has been around for a long time, but all you really need to know that you shouldn't really use it. So we never use gets, we only use neither we use gets, neither we use scanner, we only use wrapper. Because there is some sort of wrapping that has been done over gets to make it safe. Simple pointer expresses and rather than. We have to understand that put is a simple pointer. Yeah, put. Okay. So what we will do is print one name person LD comma size of name. Line of name is 4. And it is correct. It is correct. What is your name? AB. It is correct. My name is AB. It is absolutely correct. I don't know why it must have worked. So what we can do is long, not sure whether long into something is not. As name equal to size of name. And here we will use long name. So now we will try to compile ABC. I know it is breaking down as information earlier, but this is the correct way because here it is a array of characters. It is an array of characters. Be careful. Remember, size of returns the amount of space occupied by a variable. In the code above, put is an array variable. So size of return the size of the array. The array variable. So, but this will not happen as we have already discussed. If we pass to the function, if we pass to the function, then it is a pointer variable. And if we try to then apply the size of an increment. One second. So we understood this. But can we apply the we try to let's try to understand. Can we do the pointer arithmetic or we will try to print something? Or we have done it already. Let's check it out. So print and enable level. Let me tell you size of message. Print string size of the notebook and absolutely. Now let's try to delete it. We will delete it. So what I'm trying to do here is so I want to print that address is person p comma name. I just want to see currently it is a if we try to move it currently it is a character array of characters. So it is an array variable. So it is an array variable right now. So let's try to see how it will print. So it correctly prints the address. Let's try to get the value. Value is okay. And what we will do here is we will print the character. And if we try to understand, it will point to the first It will basically it will point to the memory which store the first character. So what we are trying to do here is so we copy this, paste this, and now sorry, and now we will increment it by 1. Right? Now let's see. Let's see. My name is H, value is H, value is U. So pointer arithmetic is still possible if it is a character array. If the variable points to a character array. Okay. Food is an array variable. So pointer arithmetic is still possible here if food is an array variable. And size of operator will also work. But if we are passing it in some specific method, let's assume we have created a method int delete, okay, and we are passing it in as char, sorry, name. Here we are passing it as, now it is a pointer. So if we are going to print, if we are going to copy this, oops, inside delete, okay, now it is throwing an error. You can clearly see. So we have done the same thing what we were doing here, because now it is not a array variable. Now it is not a character array variable. It is a pointer to a array. Okay. Now it is a pointer to a character array, and this operator will not work here. It takes a pointer to a button. What we have passed it was also a pointer to a button. So let's move on forward. Title bytes. Scanf can limit the data enter so as long as you enter the format string. FCAT has mandatory limit, nothing is passed. Yeah. Multiple fields. Yes, scanf will not only allow you to enter more than one field, but it also allows you to enter structured data, including the ability to specify what characters appear between the fields. FCAT take this only one on the chain. FCAT allows you to enter just one string into a buffer. Okay. Okay, but scanf has this advantage, structured data. Spaces. Scanf gets hit badly by this one. When scanf reads as string, it stops as soon as you hit the space. So if you want to enter more than one word, you will either or using fancy regular expression trick, hold data of the string every time. So most of the cases are here, like we want to read the string or space, or we want to hit the number three. So scanf if the enter is single unstructured data, then I get good. So here. In the back room of the Headfirst Lounge, there's a game of three-card Monte going on. Someone shuffles the card around and you have to watch carefully and decide where you think the queen card went. Of course, being the Headfirst Lounge, they are not real cards, they are using code. Here are the program they are using. So we can clearly see this time, rather than using an array of characters, they are simply creating a pointer to a character and passing it as string. So definitely this cards will point to the. Let's check it out. Let's check it out. So let's check it out. So what they are trying to do here is they are creating a character pointed to a character. Let's say count equal to, and then they are passing it JKL. Okay. Now if we want to print the first one, for example J, what we will do? We will print a %C, comma. So count is a pointer to an character, so it will automatically store the address. And now what we have to do here is we have to pass a value. So if we again compile it and run it uh, here, so here you can see it is printing J. So let's show until now, rather than using count, what I am going to do is increment count by 1. Okay, rather than using count here, I am going to increment count by 2. So now when we will run this code, now we will run compile and run this code. So it will print VK. So this annotation is exactly similar to this annotation. We understood that. Now let's move forward. And this is also similar. But here cards 2. Okay. Now cards 2. This is a problem. Card is of length. Okay, sorry. Cards 2. So it is referring to cards 2. Oh, this is also a good thing. We can test it here. What will happen if you do print a percent d comma. So this is also the same notation. Count if we do 0, 1, 2, yes. This is also the same notation. We have already seen that. So this is the same notation. So that means that cards 2 is 0, 1 to k. A card says k. Okay, we can add a comment there. K. Now cards 2 equal to cards 1. So value at this specific location 0, 1, 2 equal to cards 1. So now cards 2 will have 2 means 0, 1, 2. Now the value will be J to cards 1. Q. Okay. Now cards 1 equal to cards 0. No confusion. So cards 2 equal to cards 1. Now they are changing cards 1 equal to cards 0. Cards 1 will be cards 0 J, and card 2 is also point to card 1, so it will also be J J J. Okay. Now cards 0 will be cards 2, cards 2 will be cards 1, and cards 1 equal to A cards. So A cards is also pointing to 0, and they have now written put cards, put, and they have passed cards 1. So I think J J J return 0. The code is designed to shuffle the letters in the 3-letter string. Remember, in CS string is just an array paper, the pointer should be the player places their bets on whether they will find a Q letter, and then the code is compiled and run. Okay, so they will find the Q letter. But as per my analysis, everything will be GJJ. Value at this specific location will be value at this specific location will be this specific location. This specific location and then here. Let's see. So compile, program compile. Right? Let's start with the code. String can't be updated. Outside the string something else. That's one. That's two. That's zero. That's one. That's two. That's zero. That's two. And A card. Value at here. Card. That's also string can't be updated. Next level is for the types outside the string. No, we are not doing it. String is going to be the memory. Why is it in the memory? It is in the memory. We printing it on. No, the string can't be updated. Okay, okay, okay. So if I try to modify it, I'll do it. Okay. Immutable. Okay. Immutable from four down. Okay. Okay. Can't be updated. So what about if you try to update the name? Can you try this or not? Name 0 equal to B. What happened? Sorry, B. B is it okay? My name is O. Value is B. There is nothing. 0 equal to B. There is nothing. For them. So you can update an array of characters, but you cannot update if you create a string like this. Interesting. Because I don't, the problem is the address is not known here. Because here we have already defined that the length will be 4. Okay, the length is 4. So it knows that first character is at this, the second character is at this, the third character is at this, and sentinel character is at this. But here it is unknown. It is totally unknown. So that's why it cannot be updated. Let's try to understand what is the reason being given by the book. String literals can never be updated. This is called string literals. Okay, that is an array of characters, and this is called string literals. Okay. But if you create an array from string literal, then you can modify it. So there are two ways. You do it like this. We update it. But if you create, but if you create, so update plus equal to, but I will take video. This can be updated. Okay. It all comes down to how C uses memory. In memory, character pointer to character equal to JQK. Okay. To understand why this line of code causes a memory error, it puts all of the constant values like the string literal JQK into the constant memory block. This section memory is read only. Whenever we use something like this, puts the string literal into a constant memory block. The section of memory is read only. The program creates the cards variable on the stack. Okay, card variable is created on the stack, and the JKK sentinel character is created on the constant. Okay. The card variable is set to the address of okay. Card variable will contain the address of the string literal JQK string literal document is stored in read-only memory to prevent them from any changes. The computer tries to change the string. When the program tries to change contents of a string pointed to by the cards variable, it can't. The string is read only. I can't update that, but it's in constant memory block, so it is read only. Code constant global heap stack. But if that's the problem, how do we fix it? If you are going to change the string, make a copy. The truth is that if you want to change the contents of a string, you will need to open a copy. Okay. If you create a copy of string in area of memory that is not read only, there won't be a problem. If you try to change the letter it contains, but how do you make a copy? Well, just put a string as a new array. So this can be changed. This can be changed. Card is not just a pointer. Cards is now an array. So it is not a pointer now, it is an array. So we have to understand that. We cannot change a string little, but we can change an array of characters. It's probably not to clear why this changes anything. All string are arrays. But in the old code, cards were just a pointer. In the new code, it's an array. So that is the difference. That is the difference. Earlier it was a pointer, but now it's an array. And for pointer also, but where it was pointed to, it was pointed to a location memory which is in constant space. And constant space is normally read only, that does not allow us to modify that. Okay. If you see a declaration like this, what does it really mean? Then it depends on where you see it. If it's a normal variable declaration, then we get parts as an array, and you have to set it to value immediately. Right? Okay. Okay. But if the card is being declared as a function argument, it means that card is a pointer, which we have understood earlier. Here it is a pointer to a character, and here it is a simple array of characters, and it has to be given some sort of variable that it can store in this memory. And there is no array size given, so you have to set it to something immediately, and it understands that whatever be the length of it, for example 3, the length will be 3, and it adds a sentence character to it at the end. These two, this is most important, these two are equivalent. So either you can use this or you can use this. And we have also mentioned this in our code. Okay, so this is so we have already seen that this string content. Let me add a comment here. Offset are equal. Understood. Okay, so I think this is enough for today. We will look at the next section tomorrow, and we can go through all this again because it is very, very important, and it will be very helpful us to understand the memory and pointer, and this is the most important chapter, I think, and it will be helpful for all of us. So thank you for bearing with me, and you can watch the recording completed also. Thank you. Have a good day.